What if I told you that in just a few minutes, we can turn our custom YOLOv8 model into a fully functional, real-world web application, with Gemini AI double-checking our results? In my last video, we trained this YOLO model from scratch. Now, let's build the backend. We're using FastAPI for a lightning-fast server, Ultralytics to run our trained best.pt weights, and the Google Generative AI library for advanced OCR. Here is the core logic. We create an endpoint that accepts image uploads. Once the image is received, we decode it with OpenCV and pass it directly to our YOLO model. If YOLO spots a license plate, it extracts the exact bounding box coordinates. But here is the secret sauce. We crop that specific plate area and send it to Gemini 3.1 flashlight. Why? Because traditional OCR struggles with dirty plates or weird angles. Gemini acts as our failsafe, reading the text with near-perfect accuracy. Let's fire it up. I'll open the terminal, run python app.py, and our Unicorn server is live on localhost. Let's see this hybrid AI architecture in action with some real, unedited CCTV footage. I built a clean drag-and-drop UI. Let's drop our first truck. Look at that. Instant detection. The YOLO model finds the plate, and Gemini extracts the exact characters. Let's try a different truck. Perfect. How about a standard passenger car under a completely different angle? Flawless. This hybrid approach solves the biggest problem in computer vision: reliability. Even if the camera quality drops, or the plate is slightly obstructed. Combining a local object detection model with a cloud-based LLM gives you enterprise-grade results for practically zero cost. Here is a tough one. Zoomed way out. Still catches it perfectly. This system is ready to be deployed at a real way station or factory. I've left the entire source code for this full stack project in the description below. Hit that like button, subscribe for more practical AI engineering, and I'll see you in the next one.